Okay? Question that we are given. So the question that we are given, you're given you're given, which is 4 kilograms, and together by 2 identical K. So this is string 1. They are each of length L. Now, and the combination is found in a vertical circular path, moving like that. Okay, in a vertical circular path. Okay. The path, just for the sake of recording, so it's moving like that, found in a vertical circular path, in such a way that the strings are collinear. What does it mean for the strings? Sorry? So they are on the same, okay? Line, linear. Is that okay? So co means same, okay? So the strings are in the same line, collinear. So when these two bodies are at that point, okay, these strings are also in line, in one line like that. Is that okay? So now you don't get anything where, for example, you have that's M2 and that's M1. You don't get that. They are always in the same. Is it clear? So that's the case all the time. Its motion, M2 is traveling at that speed. So at the top, which is this position shown there, M2 is traveling at 4 meters per second. M2 is traveling at 4 meters, and then you are asked to find the tension in string 1, the tension in string 2, and then to determine which string will break first. Then explain your reasoning, right? Give a reason for your answer. Is there any part of this question that you do not understand? Is there any part of this question that you do not understand? Sorry? Anyone? Which part?
For M1.
Yes, M1.
The tension when you're drawing the free body.
Okay, no, we are just talking about the question before we go to the solution. Okay? Is there any part that you do not understand in the question? So is it clear what the bodies are doing? Okay, good. Now, if that is clear, yes. Okay, so that's part of the solution. Okay. At the radii of these two, okay, so M1 through this circle, is that clear? That's M2 goes through the outer circle, is that clear? And they both share this, is that clear? So is the radius for this circle the same as the radius for that circle? Not the same. Is the radius for the inner circle the same as the radius for the outer circle? Good. So with that in mind, so let me see if all right, I'll explain it also. So with that in mind, there are a few things that you need to be careful. So we need to draw the free body diagram so that we can solve the problem. But let me explain a piece of physics that most of you missed. If you have two bodies, okay, that's the center O. So you have two bodies, that's body 1. Okay, let me use the number here. So that's M1 and that's M2. Is that clear? Is that clear? Okay. And they are at that position, okay, and they are moving together in the same line, collinearly. Is that okay? Now, when they get to this position, suppose they are moving up. So that is now M1 there, M2 there. Okay? Is their speed, linear speed, the same? Give me an answer. You understand what I mean by linear speed? Huh? Understand the question? Good. So the linear speed is the distance traveled divided by the time. So the actual distance that you can, the length, that's why I'm saying linear. Is that okay? So the linear speed is the distance traveled by divided time. So in other words, for body M2, the distance traveled is this here, okay, which is S2. Is that okay? And for body 1, the distance traveled is that there, which is S1. Is that clear? Okay? So the linear speed for M1 is V1, okay? So the linear speed for M1 is V1 by the distance divided by the time, okay? So that will be S1 divided by the time t. So they move from this position same time t, is that right? Okay? And then for M2, which is equal to the distance traveled, which is S2 divided by the same time t. Is that okay? Now, question. Is V1 equal to V2? Are you clear now? Lady? Still confused? No. Okay? So V1 is not equal to V2. So V1 is not equal. Is that okay? Is everyone okay with that? Please raise your hands or speak up if you are not okay with that. Can you see why they are not equal? Because the distances covered are not the same. Is that okay? So this one covers a bigger distance than that one. Is that okay? Right. So what does that mean? If these two are collinear, okay, what does that mean? One has to move faster than the other. Is that right? Okay? So which one is moving faster than the other here? Faster than M2. Is that okay? In order to catch up with M1, in order to catch up with M2 at that point. Is that okay? Okay. But there's something that is the same except the time. The angle is the same. Is that okay? Is that okay? Okay. So if the angle is the same, so we can talk of the two angle theta 2, and they are both just theta. Is that okay? Okay. So they're just both theta. Right. Now, if I divide, if one is faster than the other, so it's actually fast, so that linear. Exactly. So the one moving on the outer circle has to run fast, has to move faster than the one in the inner circle, so that it catches up. You guys did sports at school, athletics. Now, when you get the 200-meter race, around that curve, the one on the outer side would have to, which they didn't, okay? If they started from the same line, then the one on the outer side would have to run faster than the one on the inner side. Is that right? But they were displaced to make up for that, okay? But that's okay. Are we fine? Okay. Is there another hand? Okay. So if the two, I can divide the two angles by t. Is that okay? It's the same time t. Is that okay? But now what have I defined? So initially we said v is the linear speed because they're measuring the length, linear length. Is that okay? Is that right? But here, what did I define? So it's the angle divided by the time. So what is it? The angular speed. Is that okay? And the angular speed is called omega. So for theta 1, for M1 it's omega 1, for M2 is omega 2. Is that okay? Is that okay? So if you have two bodies moving collinearly, as given in that diagram, the linear speeds are not the same, okay? but the angular speeds are the same because they have to cover this main collinear. Is that part okay? Okay, good. If that is okay, so that's what you have. So the angular speeds are okay, but how do you calculate the angular speed? Okay, I wrote it down somewhere. So if I use that, I derive it. So omega is just V on R. Is that okay? So omega 1 will be V1 on, and omega 2 will be V2 on R2. Is that okay? Because omega is just V on R. Make sure I can do this. Are we fine? Okay. So if that is okay, in the problem, I'm given the speed of M2, okay? So if I want the speed of M1, it's not equal to the speed of M2. That is, it's not the same, okay? But I can find the speed of M1 from that of M2. Is that okay? So this equation here, which is V1, is equal to the ratio. Is that right? Times V2. Is that right? Okay. Make sure I can do it. Are we finding this now? For the speed of one of them, I can determine it from the speed given the ratio of the radii. Yes? You don't understand this ratio? Okay, just make V1 the sub. Is it clear now? Okay. Are we okay with that now? Okay, good. If that part, let's draw the free body diagram. Okay, now, I have to explain to you what I mean by a free body diagram, okay? When I ask you to draw a free body diagram, I ask you with or draw to a block, whatever you draw, okay? With the forces acting on that particular object. Is that okay? So all the forces must be shown. If the forces is not a correct free body diagram. Is that okay? Okay. So for M1, okay? So the free body diagram, I have a dot. I choose to use a dot, okay? So that's here. Okay, so it's a dot. What forces do I have acting on? What forces are acting on M1? Sorry? So there's a tension. Is that okay? So as far as M1 is concerned, downwards, it's pulling M1. Is that okay? So what else is acting there? So there is the weight of M1. Okay, what else is acting? Huh? Yeah, normal? Okay. Is there no more force acting there? Yes or no? How many say yes? How many say no? How many are not sure? Okay. For the sake of those who are not sure, what is the normal force? Which Newton's law tells us normal force? The second law. The third law. Is that okay? So if I have a book, if that's a table, book resting on the table, is that okay? So what force is the book exerting on the table? Sorry? So there's a weight. Is that okay? But is the book sinking into the table? Is it rising out of the table? So there's no resultant force. Is that right? So if there's no result for you, there should be another force balancing it up. Is that okay? So all the forces cancel vertically. Is that okay? So there must be another force that is exerted by the table onto normal force. And if there is no motion there, then N is equal to mg. Is that okay? Is that okay? Now, let's come to this. Is M1 resting on anything? Okay? So, would you expect a normal force? A normal reaction? Okay, good. We are drawing free body diagrams. So, we are drawing a body for M1 free, and we'll draw a body for M2 free. Okay, so let me explain what you mean by free body diagrams. Cover that, okay? Look at the free body, and you draw. Is it clear? Is it clear? That's what it means. And then you want to draw the free body diagram, cover everything else, okay? Look at the forces acting on it, you draw the forces acting on it. Is it clear? What you're asking is absorbed in the mathematics. Is that okay? Okay? It's absorbed in the mathematics. Out correctly. Yeah, we'll talk about that just now. So you are going to tell me what? Okay? So for M1, okay? This is for M1, okay? Body diagram. So we have the tension T1 and M1G, the weight, okay? Right. The radial acceleration at that point. In which direction is the radial acceleration? Sorry? Upward is the center. Down, okay? So at that point it's downwards. Is that okay? Okay, good. So the resultant force is towards the center, downwards. Now for M2, so for M2, I have so for M2, which forces are acting? So cover everything else, ignore everything else. Just look at M2. Which forces are acting? T1, which is the tension in string, in that string. In which direction is T1 as far as M2 is concerned? M2 thinks or feels T1 pulling it upwards. Is that okay? Right? It's acting. The weight, okay? So there's a weight of M2 there. Is that okay? Is that okay? Right. What other force is acting? T2. In which direction is T2? And it's in the string 2. Okay? String 2 there. That's T2. Is that okay? So as far as M2 is concerned, there are three forces. So that's the free body diagram. So the weight, T2, and T1. Is that okay? The acceleration, the radial acceleration, is towards the center. The resultant force, the radial is it. In which direction is the radial force? It's also downwards towards the center. Is that okay? Good. So once you've figured that out, everything should be fine. But I noticed someone move from a free body diagram to an equation. Okay? So let's move from the free body diagram to the equation. Okay? So for each, you can write an equation. Okay? And the Newton's law that you're going to use to write the equation is Newton's second law of motion. Okay? So the resultant, the sum of the forces should be equal to the mass times. Is that okay? Is that okay? M1, and we're looking at the radial. Okay? What is the sum of the forces? So it's the radial forces. Is that okay? On R, okay? So M1 is the radial force. Okay? What is the sum of that? And that radial force should be equal to mv squared on r. Is that okay? V squared on r is the centripetal acceleration. Okay? So that's the acceleration then. Now, so what is the sum of the forces? So the sum of the forces is towards the center. That's where the resultant is. So what is the sum of the forces here? Some of you are messing up the signs. All right? Some of you are messing up the signs. So what is the sum of the forces for M1? So we are here. So what should I write for the sum of the forces? 1G. Okay? Should I put negatives? Why not? Okay? So T1 plus M1G should V1 squared on R. The same thing applies that side, but we'll talk about it just now. All right, let's talk about it now. On M2, what's the sum of the forces? What should I write for the sum of the forces on M2? Okay, so everything downwards should be equal to centripetal acceleration. Is that right? So it's T2 plus M2G minus T1 should be equal to M2 times V2 squared on R. Is that okay? Okay, good. But now, what is R1 and what is R2? We are back to you. What is the radius for M2? What is the radius for M2? Okay, so it's just L there, which is 0.5 meters. Okay, what is 1? It's 2L, which is 1 meter. Is that okay? Okay, good. So from that, R2 is L. So you put that where you have your R1 and where you have your R2. Okay, and so from this here, this should tell you what T1 is. Is that okay? So that you're making it the subject. That's the tension in 1 and 17 Newton. Okay? 217 Newton to 3 significant figures. And then you solve the other one. It contains, but already know what T1 is. So you put what T1 is. Okay? You're just making T2 the subject. Okay? And you get 283 Newtons. Is that okay? Right. For the free body diagram, you got a mark. That free body diagram, a mark. For that equation, a mark. For that equation, a mark. The final answer there, 217, a mark. The final answer, 283 Newtons, a mark. Okay. Part was which string will break, and so if these continue to move faster and faster, okay, the tension would continue to break first, and you should give your reason. Okay, so before you know which string you're looking for, how do you know which string would break first? Bigger tension. Is that okay? Is that okay? What does it mean to have a tension? It means you are pulling it apart. Is that okay? So the one that's being pulled by should break first if the two are identical, which is the case here. So we have a bigger tension, 283. It's bigger than T1, which is 217. Okay? So T will break first because it has a bigger tension. Is that clear? Is that clear? Okay? So for me, that string 2 would break first. That was a mark. And for arguing argument that it's because it has a bigger tension, that's another mark. Any questions?